Start our session now. Okay, now we will revise. I will revise your previous lecture. Actually, in previous lecture, we discussed about basic concepts. Okay, so stress, then next vibration, then we have studied about your degrees of freedom concept. Okay, so now we will start our session with continuous problem and discrete problem. Okay, so actually in last lecture we studied about continuous problem. So what is the continuous problem and how it is going to convert into discrete problem. So continuous problem means this is your continuous approach, or real life problems are considered to be a continuous problem, means there is no physical gap between the because we are considering all real life problems as a continuous problem, means there is no physical gap between any two consecutive particles. As the material science approach, this object is made up of small particles, and these particles may be molecules or maybe atoms, and these these particles or atoms are bonded together by strong attractive forces. So solving this type of continuous problems is difficult actually for your finite element method, or for different numerical methods. We need to simplify this continuous problem by discretizing into discrete problem. Discretizing means meshing, or meshing means discontinuation of a continuous problem into a discrete problem. Okay, so in simple words, this discretization is based on the principle of making nodes and elements. Okay, so we will see the first this one example of continuous approach and discrete approach. Okay, so this is your continuous approach, means this person is sitting on this chair. Now we need to convert this continuous approach into discrete approach by considering the number of elements. Now for this chair, this is supported by by these four legs. So this leg is considered to be a beam element in your discrete problem. So there are four legs and these four supports. So these are converted into discrete problem by considering your four beam as well as these four supported beams. So there may be 8 beams, and this plate or this support is considered to be equivalent to your shell element or plate element. So there are only this plate element 1, these 4 plus 1 5, 5 plus these 4, so 9 elements are there. Okay, means 9 parts are there, because we are converting our real life problem or continuous problem by discontinuing it with the help of these elements. So there are only now 9 elements. These 8 elements are of beam element, and this one is nothing but your shell element or plate element, and this person's weight is acting centrally at this point, means this is considered to be a lumped mass at center of gravity. So actually in your dynamics of machinery, you have gone through the basic concepts of a system. Actually any mechanical system is a it's an equivalent system of mass, spring, and damper. Okay, you have gone through these concepts in your first introductory part. Your in your this dynamics of machinery subject, you have gone through this concept of equivalent system to any continuous problem. Okay, so this any mechanical engineering point of view, any component or system could be represented by 3 basic elements. First one is mass, second one is spring, and third one is damper. Okay, and based on this, actually this continuous problem is converted into the differential equation. It's a differential equation. How? 1 minute. One minute. admit. Actually 3 to 4 people are in waiting room, so that's why. Okay. Okay, at the same time I have to admit them, so that's why. Okay, sorry. So this is your three basic components. There are three basic components for any equivalent system. First one is mass, spring, and damper. Actually, you have gone through this system, and there are some equations like mx double dot plus cx dot plus kx is equal to 0. This is the differential equation for your free vibration system. Okay, ते तुम्हाला माहित पण असेल की actually how this equation can be derived from this system. Means this is your mass. To balance this mass, we need to apply some inertia force in vertically upward direction. Similarly, this is your spring force. We need to apply your spring force in opposite direction. Then this is your damper force due to velocity, or it is considered to be a velocity force. We will apply this velocity force again in the horizontal direction, and then by summation of these all these three forces, you will get this equation. Means your inertia force means mass into acceleration. Mass into acceleration means m into x double dot. X double dot is nothing but acceleration, d square x by dt square, dx square by d square x by dt square. Okay, this is the acceleration. Then k cx dot, x dot means your velocity, dx by dt, and k into x means your displacement. So by assuming your summation of x is equal to 0 in vertical direction, you will get this equation as mx double dot plus cx dot plus kx is equal to 0. Okay, actually you have gone through this equation in your first or second lecture during your dynamics of machinery subject. Okay, so this is the mechanical system or equivalent system, which includes three parts: mass, spring, and damper. Okay, now we will see why this meshing is required. Okay, why do we carry out the meshing, or what is FEM? Okay, as we know, the degrees of freedom per point in a space is equal to 6. Okay, for in a space, if any object in there, so for this object there are 6 degrees of freedom in translations in xyz and rotationals about xyz. There are 6 degrees of freedom for any object in a space. Suppose this is your continuous problem, so there are infinite number of points in this continuous problem. So degrees of freedom, if we consider the degrees of freedom per point is equal to 6, okay, then total equations will become number of points into number of degrees of freedom per point. So this will become infinite number of equations, but we cannot solve this infinite number of equations, number of algebraic equations by our analytical method. But if we convert this infinite or this continuous problem into discretized problem, if we can, if we, 1 minute, one person is waiting in the waiting room. Okay, now if we convert this continuous approach into discretized problem, then we will convert this entire domain into finite number of elements. Okay, so this is first element, this is your second element, this is your third element, and this is your fourth element. Okay, so there are 4 elements. So number of nodes here, number of nodes, admit on. Okay, so here total number of nodes equal to 8, and degrees of freedom per node is equal to 6. So total number of equations will become 8 into 6 is equal to 48. So 48 equations. Actually, we can solve this limited number of equations by applying our boundary conditions. 1 minute. Okay, so these equations can be solved by using our MATLAB approach or our analytical approach. But if the number of equations are infinite, then we cannot solve these equations by our simple theory or simple techniques. Okay, so we need to carry out. So this is the necessity of meshing. Okay, Now we will see the basic theme of FEM. What is FEM? What is the definition of FEM? Okay, so FEM, it is nothing but a numerical method. Firstly, it is a numerical method, as we have studied about various types of methods to solve any engineering problem, in which there are three methods. First one is analytical, second one is numerical, and third one is your experimental. So your FEM, finite element method, it is a numerical method. Next thing is, it is a mathematical representation of any actual problem. Okay, and third one is, it is approximate method. Actually, these solutions obtained by this finite element method, it will converge towards your exact problem. Okay, now definition, simple definition of FEM. Actually, it is hidden in its word itself. So basic theme is that to make calculations at only limited number of points. Okay, so basic theme is that make the calculations at only limited number of points, means make the calculations at limited number of these nodes or finite number of nodes. Then interpolate these results. Then interpolate these results, means results obtained at these limited or finite number of nodes over entire domain by using your interpolation function or shift function. Now interpolation function, so what do we mean by interpolation function? Actually, you have studied these interpolation functions or types of interpolation functions, means linear interpolation function, parabolic interpolation function, hyperbolic interpolation functions in your NM1, numerical methods and optimization subject. Okay, so we will see it in detail also. So basic theme is what? Finite element method, it is nothing but a technique or a mathematical technique tool where we can do or we calculate our results at limited number of points only, or we can do a calculation only at finite number of points, or here points is nothing but at nodes, and convert these results over entire domain, means over entire domain we can convert these limited results over entire domain by using our interpolation function or shift function. Okay, so shift function, it may be linear, parabolic or hyperbolic. Okay, we will see in detail in your shift function concept. Okay, so this is the basic definition of your FEM. So it is nothing but make calculations at only limited number of points or at limited number of nodes and then interpolate these results for entire domain. Okay, so domain may be surface or volume. So finite, so what do we mean by the meaning of word finite? So any continuous object has infinite degrees of freedom. Actually, we have gone through this. So any continuous problem or any real life problem has infinite degrees of freedom, because at any, it will include infinite number of points. So at one point there are 6 degrees of freedom, so total number of equations will become infinite numbers into number of degrees of freedom per point. So 6 into infinite, it will become infinite number of equations, and it is not possible to solve such problem in this format. So finite element method or FEM or FEA, it will reduce the degrees of freedom. Okay, in continuous problem or in real life problem, the degrees of freedom will be infinite, but your FEA or FEM method, it will reduce the degrees of freedom from infinite to finite by using some technique, and this technique is nothing but your discretization or meshing with the help of nodes and elements. This is the first basic concept. Okay, finite means converting infinite number of degrees of freedom into finite number of degrees of freedom with the help of meshing or discretization. Okay, by using nodes and elements concept. Then next is element. Now element is what? Actually we are doing, or we are going to do calculations where limited number of points. Okay, these points are known as nodes, and the entity joining the nodes and forming a specific shape such like a triangular or any quadrilateral shape. This is known as the element, means the entity which are joining the nodes and forming some shape, some specific shape, which may be triangular or quadrilateral, this shape or this entity is called as element. Okay, it may be triangular or quadrilateral. Okay, so and to get the value of variables means to get the results, say let us say displacement or stresses, we need some interpolation function. Okay, by using this interpolation function, we will interpolate these results from finite number of points to over entire domain. Okay, and next one is method. Method is nothing but, as there are three methods, first one is analytical, numerical, and experimental. So it is not, it belongs, this finite element method belongs to your numerical method category. Okay, so the basic theme of finite element analysis or finite element method is that make the calculations at only limited or finite number of points. Points, it may be nodes, or you can say that nodes. So first, make the calculations only at limited number of nodes, then interpolate these results for entire domain by using interpolation or shift functions. Okay, this is the basic theme of your finite element method. Okay, now we will see this in detail, like, okay, so discretization, as previously we studied about discretization, means converting your continuous problem into discrete problem. Okay, so discretization means what? It is the actually model the body by dividing it into an equivalent system of many smaller bodies. The smaller bodies काय आहेत ते तुमच्या elements, convert entire domain into finite number of elements interconnected at points, and these points are called as nodes. Okay, so this is the concept of discretization or meshing. Actually we will meshing, we are going to study this concept to your practical approach also. During your practicals, this meshing is nothing but, for this we are going to use your hypermesh software. Okay, now these are the types of elements. आता आपण elements बघितले, nodes बघितले. So these are the, we will see, so different types of elements. So this is one dimensional elements, you can say, you can call it as a line element. Okay, so this is element. So for this one dimensional element there are only two nodes. Okay, then next category is two dimensional elements. This is your two dimensional elements, it may be triangular or rectangular, or its examples are membrane, plate, or shell. Then a three-dimensional elements or solid elements. Okay, these are the solid elements. Examples are bricks, or this is considered to be a solid or three-dimensional element. Now, next we will see. Suppose this is your truss structure. Okay, this is your base, and at these 2 points, suppose a vertically downward force is acting at these 2 points, and these are the support members. Now this is your continuous problem. Okay, now we will convert this continuous problem into our FEM problem by converting it in a discrete manner. Now it means converting this whole problem into number of finite elements. Now how it will take? So see, these are the elements, means continuous problem is converted into finite number of elements problem. So there are only three, 1, 2, and 3 elements. Now nodes कसे असतील बघा. So these are the nodes. So there are 1, 2, 3, 4, 5 nodes are there for this problem. Okay, so suppose if we consider the force of 100 kilonewton acting vertically downward at these 2 points, and suppose there are supports like roller support or hinge support or pin support. So supports, the supports on, basically support means what? 1 minute. Okay, waiting room. Okay, let us see. These are the supports. One minute. Okay, so what are the types of supports? Now we will see what are the types of supports first. So for this supports, okay. So there are basically three types of supports. First one is roller supports. Second one is your roller supports. Then next one is fixed support, and third one is pin support or hinge support. Okay. So which type of reactions are acting during your roller supports? Okay. So this is your roller supports. For example, this is your roller supports. So in this case, only vertical forces. Okay. So roller supports can resist a vertical force, but not a horizontal force. Okay, so this is your roller support. It can resist only vertical load, but there is a movement in a horizontal direction. So this is your roller supports. The next second one, okay, so see, this is your roller support. It will resist only vertical load, but in horizontal direction the movement is possible. This is your roller support. So next, see, this is the roller support. Next one is fixed support. So fixed support, it is the most type, actually it is a rigid type of support. Okay, it constrains the members in all translations and rotations. That is, it cannot move or rotate in any direction. So for this fixed supports, so this is the fixed supports, means horizontal as well as vertically force can be constrained, or rotation also constrained in this fixed support. And next one is your pin support. Okay, let us see. Third one is your pin support. Actually, it is called as a hinge support. Hinge support. Okay, this hinge support allows rotation to occur, but no translation. That is, it resists horizontal and vertical forces, but not a movement. And this is your pin support. So example is this pin support. So it will resist horizontal and vertical forces, but not a movement. So these are the three types of supports. Okay, so they will act at this place. So these are the nodes 1, 2, 3, 4, 5. Forces will act at these two nodes, and supports may be at these three nodes. And we are going to find out the displacements, then strain and stress. Okay, so this is the example of FEA, one-dimensional beams, means truss structure. In your hypermesh software, we are going to model the example of truss using this rod element or beam element. Okay, this is your one-dimensional beam problem. Then next is, this is your two-dimensional FEA problem or plate structure. Two-dimensional plate structure. Two-dimensional means there are only two dimensions which are comparable as compared to your third dimension. Plate, for example, if you consider the plate, only width and breadth is considerable or measurable, but thickness is not measurable. Okay, because it is very, very less as compared to your other two dimensions. So it looks like a two-dimensional problem in your hypermesh software. And next one is your three-dimensional problem. Three-dimensional means all the dimensions are measurable, okay, or comparable. This is your about your three-dimensional problem. Now next we will see the types of engineering analysis. Okay, so types of engineering analysis. So first, there are 4 to 5 types of engineering analysis that we can solve by using our finite element analysis procedure or applications. Okay, means there are 4 to 5 softwares that are used to solve your structural, vibration and heat transfer models. So let us see one by one. Structural analysis. Okay, so structural analysis actually it consists in linear and non-linear models only. Okay, so linear means linear models actually use the simple parameters and assume that the material is not plastically deformed. Okay. So during your linear models, stress is directly proportional to strain, or up to elastic limit, you can consider it as a linear model. Okay. But non-linear models consist of stressing the material past its elastic capabilities. Okay, means your plastic deformation, it will consider in a non-linear models. Okay, and in which we are going to calculate the stresses and strains in the structural problems. The next one is your vibrational analysis. Now, in vibrational analysis, we are going to find out the natural frequencies of any system. Okay, so it is used to test a material against random vibrations, shock, and impact. Actually, basic theme is to find out the natural frequency of the system. Okay, and it will actually, these incidences may act on the natural vibrational frequency of the material, which in turn cause a resonance and subsequent failure. So to find out the natural frequencies, we need to go through, or we need to take a vibration analysis. The next one is, this is the example. Okay, so let's see this example of analysis of the vibration in the bridges. Main motive is what? To find out the natural frequency. The next one is fatigue analysis. Now, fatigue analysis actually, it helps designers to predict a life of a material or structure. Okay, to predict the life of a material or structure by showing the effect of cyclic loading on the spacing. Okay, so this is the example of analysis of fatigue in frames of a locomotive. Okay. So in this analysis, actually this analysis can show the areas where the crack propagation is most likely to occur due to this cyclic loading. So failure due to fatigue may also show the damage tolerance of the material. Means, so this type of analysis, why need to carry out such type of analysis? To find out the areas where the crack propagations will occur due to the cyclic loadings. Okay, so fatigue analysis is there. The next one is your heat transfer analysis. Actually, heat transfer analysis models the conductivity or thermal fluid dynamics of the material or structure. Okay, so this may consist of a steady state or transient transfer. Now, steady state refers to constant thermal properties. Actually, in this we are going to find out the temperatures at different points and the heat flow during the heat transfer. Okay, so this is actually used to find out the temperature and heat transfer. So this is about your heat transfer analysis. Okay, so these are the basic. There are four, actually we've gone through four basic analysis. First one is structural, second one is your vibration, third one is your fatigue, and fourth one is your heat transfer analysis. So in structural analysis, you will get first stresses, second strains, displacements. In your vibration analysis, you will get frequencies. In third one is your fatigue analysis. During your fatigue analysis, you will come to know the area where the crack propagation will take place due to the cyclic load. And third, last one is your heat transfer analysis. In your heat transfer analysis, you are going to find out the temperature distribution across the section, as well as the heat flow or flow of heat through the section. Okay, so this is about your analysis, right? Analysis concept. Okay, so if you have any doubt,